When we hear the word mathematics, what comes into mind is numbers. In fact, numbers are the heart of mathematics, but on their own, they only form a tiny part of it. Here in this video, you will see what mathematics is all about. We live in a world where we apply math every day. We count eggs for breakfast, pay fares in jeepneys, and use subtraction for change. Mathematics is just like reading and writing. Without it, can be a huge disadvantage. Let's start with my first point, which are numbers. The most simplest part of numbers are counting. In fact, counting began long before there were symbols like 1, 2, or 3, because it is possible to just count by using your fingers. Did you know that people before, when they used to count, for example, their sheep, they use a token and a bag? What they do is every time a sheep passes by them, they drop a token into the bag, and that token represents one sheep. The use of symbols for numbers was probably developed 5,000 years ago when counters were wrapped in a clay envelope. People find it annoying to break the clay covering every time they check the contents and make another one after they are finished. So what they did was they put markings on the outside of the envelope summarizing what was inside. Afterwards, they realized that they do not actually need any counters inside and that they can make the same markings on clay tablets. The next form of numbers after counting are fractions, the kind of numbers we now symbolize as 1/3, 2/4, and the like. Fractions cannot be used in counting but can be used in many different interesting things. Examples are measurements for cooking, it is used for inheritance, and it is used to represent division.
Mathematics is about numbers, one of which is zero. It was invented and accepted as a denoting number between the 400 and 1200 AD, thinking that zero took a long time for them to accept that it is a number. But it also took them a long time just to consider 1 as a number, because it was thought that a number of things should not be 1 nor 0, but several of them. 0 was a symbol and represented as the concrete idea for nothing. Mathematics used symbols, but they did not use symbols at that time. Mathematician Carl Friedrich Gauss was thought to be as the greatest mathematician that has ever lived. He said that what matters in mathematics is not notations but notions. Eventually, there was another number concept that was invented. It was negative numbers. Negative number is a number that its value is less than 0. It was thought to be a representation of death. There are many interpretations of negative numbers. One example, the temperature of degrees in Celsius, like negative 10 degrees, it means that it is colder than freezing. These are the mathematical denoted numbers by using positive and negative integers. Now let's talk about fractions. Fraction is a number used for measuring. In counting, we have 1, 2, 3, 4, 5, and so on and so forth. But when we measure something, it will not always be a whole number. Therefore, we need numbers that are less than 1, but that is part of 1, such as 1/2, 1/3, 1/4, and 1/5. There is also what we call irrational numbers. It is the simplest way to enlarge the number system because of how it is represented by decimals that goes on forever. Lastly, without real number there would be no mathematics and we would not know how to count. Real number is the most common numbers we think of in our daily lives, such as a whole number like 0, 1, 2, 3, 4, and so on, are known as the natural numbers. If negative numbers are included, we call them as integers. Positive and negative fractions are called rational numbers, while real numbers are more general but sometimes complex numbers. So we have 5 number systems. Following are natural numbers, integers, rationals, real numbers, and complex numbers. That's all.
However, mathematics is more than just about numbers. We've encountered different kinds of object of mathematical thought and operation. Examples are the addition, subtraction, multiplication, and division. In general, an operation is something you apply to two, sometimes more, mathematical objects to get a third object. The term for such an object is function. You can think of a function as a mathematical rule that starts with a mathematical object, which is usually a number, and associates it with another object in a specific manner. Another term with the same meaning of function is transformation. This is a term used when the rules are geometric and to capture the mathematical essence of symmetry. Operations and functions are very similar concepts. Both of them are processes rather than things. Mathematical things have no existence in the real world. They are abstractions. But mathematical processes are also abstractions. So, processes are no less things than the things to which they are applied. For example, the number 2 is not actually a thing, but a process. The process when you associate 2 passes or 2 ping pong rackets with the symbols 1, 2 chanted in return. A number is a process that has long ago been thingified so thoroughly that everybody thinks of it as a thing. The image of mathematics raised by this description of its basic object is something like a tree, rooted in numbers and branching into even more esoteric data structures. Mathematics is not just a collection of isolated facts. As nearly any particular mathematical fact, we find other related facts. For example, the fact that the circumference of a circle is 1 pi times its diameter is very close to the fact that the circumference of a circle is 21 times its radius. The connection between the two facts is immediate. The diameter is twice the radius. The creator of mathematics explores its unknown mysteries, maps them, and builds roads through them to make them more accessible to everyone else.
Now, let's talk about proof. So, proof determines the route from one fact to another. To professional mathematicians, there's no such thing as valid statement or valid reason unless it is proved beyond any possibility of logical error. But in philosophy, it is said that you can't prove anything because you have to start somewhere. And even though you have already started somewhere, there are possibility of logical error and disapprovable statements. But now, let's take a pragmatic look about what proof really is. Similar to movies and novels, mathematical proof is a story about mathematics that works. It does not have to dot every J and cross every T, but the viewers are expected to fill in the holes and every routine steps for themselves. Just like in movies, the character may show in different surroundings, but it does not necessarily mean that you have to show how they got there. The rules are stringent. In mathematics, a single flaw can be fatal. Moreover, a subtle flaw can be just as fatal as an obvious one.
Mathematics can be frustrating and illuminating in the process. Frustrating in getting the evidence and illuminating in having the proof. In mathematics, the proof is a sequence of statements. Mathematical proof concludes supported arguments of mathematical statements. Proofs must be convincing to be accepted by mathematicians. A small incorrect input in the computation, it will come up with a different solution that may differ immensely. Mathematicians started to learn to be extremely critical of proofs. According to Ian Stewart, proofs knit the fabric of mathematics together, and if a single thread is weak, the entire fabric may unravel.
Mathematics will not reward you with the glitz and glamour immediately. After having created solutions, contributed to research, or having created a mathematical equation. Before mathematicians actually publish their work, they need to find proof that validates their work. Otherwise, it will have all been for nothing. Finding proof will at times be frustrating to achieve, and is as hard to attain as creating an equation or work that is equivalent to that. It is crucial for a mathematician to find proof as early as possible and must have left no detail untouched in order for them to have proved something right and their proof would not be invalidated. Think of it as if you're baking a cake. You bake a cake, you're doing everything correctly and follow all the steps with precision, or so you thought. Your cake is ready, but it doesn't taste good and the texture is different from what you wanted. This is basically similar to finding proof in mathematics. If one small detail is missing or changed along the way, then it may lead to the invalidation of the proof, theory, equation, and many more.